Hello everyone. So in the last video we solved jump game, and in this video we are going to solve jump game 2. These two questions are somewhat similar. So if you are solving jump game 2 directly without solving jump game, I would recommend that you first see jump game solution and then and only then you should solve jump game 2. So now let's get started. Okay, so we are given a zero based index array of integer nums of length n. You are initially positioned at index 0. Now each element nums at I represent the maximum length of forward jump from index. In other words, if you are index I, you can jump at any index I plus j where j is less than or equal to nums at I and greater than equal to 0 and I plus j is less than n. Now we have to return minimum number of jumps to reach index n minus 1. Now the test case are generated such that you can reach index n minus 1. Okay, so in the previous question we see that we are only asked whether we can reach from index 0 to the last index, and in this question we are being asked how many or minimum jumps we require to reach from the starting index to the end index. So in this question also we'll solve this question using two approaches. The first one is recursive approach and the second one is using dynamic programming. So the recursive approach is very much similar to what we did in the last question solution. Okay, so first we'll solve this using recursive approach. So we have to find the minimum number of jumps to grow from this position to this position. Okay. So now let's say you are standing at this position. Okay. Now you want to move to the last position, but at this position you can take maximum of two jumps. Okay. So let's say I take two jumps, the first jump and the second jump. So in first jump I will come at 3, the first index, and in second jump if I take, I will come here at second index. Now at this part we are standing at first index. Now from first index we can take three jumps, so let's do that. So 1, 2 and 3. So we can take these three jumps. In one jump we are at second index, and if we take another jump we are at third index, finally at fourth index. Okay, now we are here. So now from here we can take maximum of one step forward. So if we take one step forward, we will be at this position. Now from here, once again we can take one step forward. So if we take one step forward, we will be at 4. Now we are at the last position. So finally we reached the last index. So this will return 0 and this will return 1. Okay, because from here to here we took one jump. Okay, so it will return 1 and it will return 2. So total of 2 jumps. So from here to here it is one jump, then from here to here it is 2 jumps, so it returned 2 here, then from here we will return another. So one jump is this one jump is this one, 2, and this one will return 2 upside. Okay, so here we got 2 from this subtree. Okay, so we got 2 from this subtree. Now we have these two branches undiscovered, so let's discover them. So from here we can take one jump. Okay, so after taking one jump we will be at 4, so this will return 0 and this will return 1, so this will return 1. So this is a single jump, so this branch has returned 2, this branch will return 1, and now at this branch this will return 0 because we are already at 4. Now the minimum from these three branches are 0, 0 from this branch, 1 from this branch and 2 from this branch. So minimum is 0. So this branch will return minimum plus 1. So this will return this 0 plus this jump. So that is 1. So this branch will return 1 in one jump, and we have the right branch undiscovered. So in this branch, if we take one step, then we will come at this one, and finally we can take one more jump to come to this 4. So this will return 0, this will return 1, and this will return 2. So this branch will return 2, this has returned 1, and minimum is 1, and this will return 2. Okay, so 1 and 2, the minimum is 1, and this jump is considered, so 1 plus 1, that is 2. Okay, so we get 2 as an answer. And which one is that answer? So one is, this one is considered, okay, and this one. So we take one jump to 3, and from 3 we directly come to the 4. So this is the branch that gave us the 2 result. So from 2 we jump to 3, and from 3 we directly jump to the 4. Now let's look at the second example. Okay, so we are standing at this position, and from this position we can take 2 jumps. So let's take these 2 jumps. So in first jump you will be at 3, and if you take another jump you will be at 0. Okay, now from 3 you can take 3 jumps. So let's take that. So first jump, second jump, and third jump. So in these 3 jumps you can go to second index, third index, and fourth index. Now from here you are standing at the second index, where you cannot take any step ahead, and you are not at the last position, right? So you will return int max, infinity, and from here this branch receives infinity, and you are standing at 1 here, that is third index, and from third index you can take one step forward. So after taking one step forward you are at 4. So you are at the last index, you will return 0 above, and this branch will return 0 plus 1, that is 1. And this branch here you are standing at 4, so it will return 0. Okay, and now this branch will take minimum of these 3 branches, this and this. So that is 0, 1, and infinity. Minimum is 0, so it will return 0 plus 1, that is 1. And in this right branch we are at 0, so we cannot take any step forward, so it will return infinity. And from infinity and 1, the minimum is 1, so it will return 1 plus 1, that is 2. So we'll take 2 steps. First we are at 2, then from 2 we go to the 3, and from 3 we directly go to 4. So this is the branch that will be taken to reach the last index in a minimum of only 2 steps. Okay, so now let's implement this algorithm. So whatever I have explained you using this tree approach is what we are going to code now. So first let's create a helper function. So we'll return minimum jump of nums from 0th index. Now if this index is out of range, we will return integer max. We will return infinity. So size is nums dot size. If index is greater than or equal to size, will return int max. Okay, now if we are at the last position, index is sj minus 1, which means we are at the end only, we are standing at the last index, which means we don't have to take any step, so we'll return 0. Now jumps is initially int max. Now we will move every step. So for example, the maximum step at idx is 3. For example, we can take 3 steps. So we'll explore all the possible path. First we'll take one step, then we'll take second step, then we'll take the third step. So all the possible path by taking these jumps. So nums at idx, we'll take all those jumps and we'll discover which one is the shortest path. So for int jump is 1, jump is less than equal to nums at idx, and jump plus plus. Now we'll do jumps is minimum of jumps, or we'll call this function by passing nums and idx plus taking this jump. After doing this, we will return if jumps is equal to int max is infinity, then we will return infinity, else we will return jumps plus 1, right? Now let's see if this works or not. So it says jump is 1, jump is less than equal to jumps at, so it will not be jumps, it will be nums at index, and it says jumps is minimum of jumps or minimum nums and idx plus jump. Okay, finally we will compare if jumps is int max else jumps plus 1. So it says undeclared variable jumps. Okay, so our initial test case has been passed, and now we will submit this. We will obviously get time limit exceeded because recursion takes a lot of time, because it explore every possible path, and from all those paths it will come up with the shortest distance or shortest jumps we took. Okay, so obviously it will be time limit exceeded. So just to recap, what we did is we'll start with the 0th position, and from that position we will try to take every possible jump that we can take, and using that we'll discover all the possible path from reaching 0th index to the last index, and in doing so we will get the minimum jump path, and finally we'll return that jumps we took in that path. Now this solution gave us the time limit exceeded, so we'll look at the second solution, and that is a dynamic programming approach. So let's look at the first example again using DP. So we have to reach from the 0th index to the last index. Now suppose that we have this array 2, 3, 1, 1 and 4. Okay, and this is index 0, 1, 2, 3, 4. Now this is DP, one dimensional. So okay, so now let's say you are sitting at this position already, you are standing at this position. So how many jumps will you require to reach the end? Nothing, right? 0. So you will require 0 jumps to reach at the last position because you are already standing at that position. Now just come back. So at this position, so you have to start with the end, and now you want to explore that in how many jumps can I reach from this position to this position, how many minimum steps required to reach from this to this position, and this to this position, and finally this, and finally from 0 to the last index. So this is a simple approach we will use in this DP. So from last index to last index it will always be 0. Now we'll come to the previous index. Now from this index, how many jumps are required to reach the last index? So you see, we can only take one jump. So in one jump, you can go to this position, right? And if you go to this position, you will discover that, okay, if I take one jump, then from that jump, so I'm standing at this position, okay? So I am standing at this position, and if I take a jump, I will come at this position. So I will ask this position, hey, how many jumps you took to reach the last position? So this position will tell, okay, I took 0 jump to reach the last position, and now this position will determine its own jump. So it says that, okay, I took one jump, and at that position it says that it took only 0 jumps. So the minimum jumps I will take is 1, right? Now let's see. At this position, I can take only single jump. So in single jump, I can reach at this position. Now this position asks this position that how many jump you took to reach the last position. So it replied back and say 1. Now this position says that if you took one jump, I will take two jumps. One jump to reach you, and you will reach in one jump the last position. Okay. Now at this position, you can take three jumps. So let's say this jump, and directly this jump. So now this position asks the next position how many jumps you took. It says 2. And this position asks the next position how many jumps you took. So it says I took only one jump. And now this position, ask this position, how many jumps you took? It says I didn't took any jumps, 0. Now this position will determine how many minimum jumps it will take. So it says that, okay, from these three paths, this path is the shortest path. So I will take only one jump to reach the last position. From this, it directly jumps to this position, and from this position, it's already at the last index. Now from this position, it can take two jumps. The first jump is here, and the second jump is here. So this position, ask this position, how many jumps you took to reach the last index? So it says only one. This position, ask this position, how many jumps you took? So it says two. So now this position is determined by minimum of these two, that is 1, and one jump is taken to reach that particular position. So it will take two jumps. And which one is those jumps? The first one is from here to here, and from here to last index. Okay, so it takes one jump to reach the first index, and from first index it jumps 3 steps to reach the last index. Okay, now let's see example 2 using DP. Okay, so we have 2, 3, 0, 1 and 4. 0, 1, 2, 3 and 4. Okay, so from last position it will always be 0. Now this position can take only single jump, and in single jump it asks the position how many jumps you took to reach the last index. So it says 0. So this position will require only 0 plus 1, which means only one jump to reach the last position. The one is this jump, and 0 jumps are taken by this position to reach itself. Now at this position it can take 0 jumps. Okay, so it can never take any jumps. So minimum will be what? It will be infinity only, because there is no minimum jumps to compare with. We will start with initially in infinity. So since it cannot take any jumps, it will be infinity only, right? Now we reach as this position. So from here it can take 3 jumps. The first jump is here, the second jump is here, and the third jump is at last index. So it asks the next position, how many jumps you took? It says infinity. It asks this position, it says that I took only one jump, and this says I took only 0 jumps. So minimum jumps taken at index 1 is 0 plus 1, that is 1. Now from this position it can take 2 jumps. Now the first jump will be at this position, the second jump will be at this position. So the minimum steps taken by index 1 is 1, and index 2 is infinity. So the maximum step taken by index 0 will be 1 plus 1, that is 2. So in 2 steps we can reach from index 0 to the last index. And which one are those? From 0th index to first index, and from first index to directly last index. Okay. So by seeing the visuals, you might have already guessed the solution. So I would recommend that you try the solutions, code yourself without seeing me coding this. So now let's code this solution. Okay. So first we'll take size, that is nums dot size. Then we have vector of int of size n, that is dp. Now we'll start with so at last position it will always be 0, right? So we'll start with n minus 2th position. So for int I is n minus 2, I is greater than equal to 0, I minus minus. So from this position we'll ask every position ahead of it, provided that they are reachable from this index. So initially nums at I, so we can take a maximum of these number of jumps, and initially the minimum jumps you require is infinity. Now we'll take these jumps and ask all those position that how many minimum jumps they required. So from int j is 1, this is the first jump, and these jumps will be less than or equal to jump size. Also I plus j should be less than n, and j plus plus. Now the minimum jumps will be minimum of minimum jump you took, or at dp I plus j. So we take the jump size jumps, and those jumps should be before the length of this array. And by taking those jumps, we ask all those positions how many minimum jumps you took, and based on that we will take the minimum of all those positions, and finally we will set this entire dp. Now one case, we in the second example we saw that we didn't took any jump, so in that case this for loop will not run, and in that case we'll check if minimum jump is already infinity, then this will be int max, else it will be minimum jump plus 1. So we took the minimum of all the positions ahead of it in the jump size positions, okay, and then we add the 1 so that we jump to that position, right? And finally, after doing this pre-processing, we'll return dp at 0. So now let's see if this works or not. Okay, so our initial test case has been failed. Let's see why. So the output is 4, but we expected 2. So let's see where did we made the mistakes. So we created size of n, we created dp of size n with all initialized to 0. Now we'll start with last second position, n minus 2 greater than equal to 0, I minus 1. And jump size is num set I. Minimum jumps is initially int max. We'll start with jump is 1, where j is less than equal to jump size, and I plus j is less than n, j plus plus. Now minimum jumps will be minimum of minimum jump and dp at I plus j, not 1. So we'll take jump from j is 1 to less than jump size, provided that this I plus j, that we took the jump at this position and this position must be less than n. Okay, and our initial test case has been passed. Now we will submit this and our solution is accepted. Now just to recap, what we did is we start with the last second position, because at the last position the minimum jumps is always 0. So from last position we can take this number of jumps, and now we will take these jumps. Now after taking these jumps, we'll ask these jump positions that how many minimum positions or minimum jumps they took to reach the last position. Now from those we will take the minimum, and after taking minimum we will add 1, because one jump is required to reach that position, and from that positions we have to take these minimum jumps. So we'll return minimum jumps plus 1. But if there is no way to reach at the end position by jumping to these all positions, then minimum jump will be infinity, and in that case we will initialize dp at I as infinity. We cannot reach from this position to the end of the array. And finally we will return dp at 0, from 0th index to last index. So that's it.